Welcome to my algebra class. We're on chapter 9, section 6. We're going to be working with word problems that involve wind and current, and we're going to be using a system of equations. So in the wind problems, in both cases, we're going to use the formula distance equals rate times time. In the wind problems, we're going to let R stand for the plane's rate with no wind. W stand for the rate of the wind. R plus W will be the plane flying with the wind. That would be a tailwind. R minus W would be the plane flying against the wind, a headwind. In the current problems, R will be the boat's rate in still water. C will be the current's rate. R plus C would be the boat going with the current or downstream, and R minus C would be the boat going against the current upstream. So with those in mind, we're going to do the evens. So turn to page 540, and we're doing problems 5 through 16. Number 6 says Camille can swim against the current at 1.5 miles per second. So against the current would be upstream. And her rate is 1.5 meters per second. And with the current, R plus C at 3.5 meters per second. Write an equation that expresses each fact. Well, we just did. How fast can she swim in still water? If I add the two together, I eliminate the current, so I get 2R equals 5 meters per second. Divide by 2, and the rate in still water is 2.5 meters per second. Problem number 8. In a canoe race, Norma travels 300 miles upstream and then returns. Norma can paddle a rate of 5 meters per second in still water, and the rate of the current is 1 meters per second. So we're going to fill out the chart that they have here. So set up your chart. So we have upstream and downstream, the rate, the time, and the distance. And the distance is 300 up and 300 coming back. It says that Norma can paddle at a rate of 5 meters per second in still water, and the rate of the current is 1. So if she's going upstream, she's battling the current. So 5 minus 1 would be 4. And going downstream, she's with the current of 1 meter per second. So that would be 5 plus 1, or 6 meters per second. So to find her time going upstream, we just need to divide the distance by the rate. So take 300 and divide it by 4, and we get 75. And then take 300 and divide it by 6, and we get 50. So her total distance upstream and downstream was at 600. And her total time is 125 seconds. or total times 125 seconds. So her average speed, take the 600, divide it by 125, and her average speed is 4.8 meters per second. Problem number 10. Flying with no wind, a plane makes an 840-mile trip in 6 hours. On the return trip, the plane flies with a 70-mile-per-hour wind. Solve the chart, fill in the chart, and figure out the average speed. So we'll make the chart. So we have no wind with the wind. Rate, time, distance. Flying with no wind, it makes an 840-mile trip. So 2, and then returns 840 miles. And it takes the first trip with no wind 6 hours. And with the wind, coming back, it was flying 70 miles per hour. So we want the rate of the first one going with no wind. We take 840 and divide it by 6, and it was traveling 140 miles per hour. And the time it took when it was coming back with the wind, had a 70-mile wind with it, so it was traveling, and I gotta erase something here. So it had a 70-mile wind, so it was going 140 plus the 70, which would make that 210, because it was going with the wind. So the 840 divided by 210 would have taken 4 hours. So the total distance was 840 plus 840, which is 1680. The total time was 6 hours plus 4 hours, 10 hours. So the average speed would have been 1,680 divided by 10 would be 168 miles per hour. Problem number 12. In a canoe race, well, we'll make another chart here again. So we have rate, time, distance, and it's a canoe race. And we're going upstream and downstream, so down and up. It says a team paddles downstream 480 miles in 60 seconds. The same team makes the trip upstream, so it'd be 480 in 80 seconds. Find the team's rate in still water and the rate of the current. Well, this was downstream is with the current, upstream is against the current. So we have 60, I'm going to erase this here, put in a different equation, 60 times R plus C, and this is 80 times R minus C. So 60 times R plus C, remember this equals 480. Equals 480, And 80 times R minus C has to equal 480. Well, I could multiply through by the 60 and 80. However, I could divide both sides by 60. And I get R plus C equals 80. And divide both sides by 80. And I get R minus C equals 60. Now I would add, this would eliminate the C, so I'd get 2R equals 20, divide by 2, and my rate is 10. And the question was the rate in still water and the rate of the current. Well, obviously I can't add. 80 plus 60 is 140 divided by 2. And again, I can't add. It's a little late. So 14 divided by 2 is 7. So the rate in still water is 7 meters per second. And the current's rate, I could take either one of these two. So 7 plus C equals 8. Subtract 7. And the current's rate is 1. So the current is 1 meter per second. Okay, problem number 14. We're still doing a distance problem, so we'll set up our chart again. So we have rate, time, and distance. 14 says it takes an airplane 1 hour and 30 minutes to fly 600 kilometers against the wind. So against the wind, so that would be R minus W. It takes 1 hour and 30 minutes, or 1.5 hours. So that's 1.5 times R minus W. And that's going to equal 600. And with the wind, it only takes 1 hour, so R plus W, 1 hour. So 1 times R plus W. So we have 1.5 times R minus W equals 600. And 1 times R plus W equals 600. We divide this by 1.5. We get 400. So R minus W equals 400. And this is just R plus W equals 600, so we can add them together. And we get 2R, the W's cancel out, equals 1,000. So R equals 500. And they were going kilometers per hour. And they want to know the total flying trip for the round trip if there was no wind. Well, this is the rate with no wind. The total trip involved 1,200 miles. So if we take the total distance, 1,200, distance equals rate times time, and divide it by 500, it would take 2.4 And the last problem, number 16. Okay, again, set up a distance chart for it says a 1,080 kilometer trip from Madrid to Paris takes 2 hours flying against the wind. So the time is 2 hours, and that's against the wind. So R minus W. And it takes 1.5 with the wind. So we have 2 times R minus W represents the distance against, and 1.5 times R plus W, the distance with. And they both equal 1,080. If we divide the first equation by 2, we get R minus W equals 540. And if we divide the second one by 1.5, oops. Let's try that one more time. 1,080 divided by 1.5 gives us 720. And then using our system, we can add them together. We'll eliminate the W. So 2R equals 1260. R divided by 2 equals 630. So the speed of the wind in still air is 630 kilometers per hour. And the wind, take either one of these. I'm just going to use this one. 630 plus W equals 720. Subtract 630. And we get 90. So 90 kilometers per hour is the wind. And that concludes the evens. Be sure you check the back of the book for the answers to the odds.